let's have our first example for this topic. A Carnot engine operates between 444 Kelvin and 555 Kelvin. What is its thermal efficiency? Okay, let's write down the givens first. We have here TL and TH, right? Of course, TH is the higher temperature, so we have 555 Kelvin. And for the TL, we have 444 Kelvin. Okay, so what is its thermal efficiency? So we are required to find efficiency. Okay, so this should be in percentage. So for the solution, you can just use the formula. Efficiency is just equal to TH minus TL all over TH. Of course, times 100 to make it in percentage. So 555 minus 444 all over 555 times 100. And you should be getting here using your calculator exactly 20%. Let's have the next one. The second example, so second law limitations on the max HP output of a power unit burning 1055 megajoules per hour of fuel with high and low temperature extremes of 833 Celsius and 45 Celsius is blank. Okay, so we're looking for a max HP output. Okay, so the final answer should be in HP, right? Okay, so let's write down the givens first. So we have what? We have the 1055. The 1055 that will be your QA. Okay. So megajoules per hour. What else? So we have TH and TH and TL, right? So TH and TL. We have 833 Celsius and 45 Celsius. Okay, so what can we do here? So we are required to find, actually this is work, okay? So we're looking for work. However, the final unit should be in HP. So what is the solution for this one? So for the solution, you can use the formulas. The formula for thermal efficiency is equal to work over QA times 100, right? However, we have another formula for this one. We also have the thermal efficiency is equal to TH minus TL all over TH times 100. Now, equating those two, since they are both equal to efficiency, you'll have something like this. So W over QA equal to TH minus TL all over TH. So, of course, I won't be writing the times 100 on both sides anymore because it will be just cancelled anyways. Okay? So, from this one, I think we can now substitute the values. So, what is the value for QA? That's 1055, right? Megajoules per hour is equal to TH and TH minus TL. That's 833 minus 45, right? 833 minus 45 all over 833. However, for the denominator, you have to convert the 833 into Kelvin because that is in Celsius. So converting that, you have to add 273. Okay, however, for the numerator, you don't need to convert that because that is already a change in temperature. So you don't have to do any conversion on the denominator because even though that is in Celsius, you can just consider it in change in Kelvin because that is change. Again, change in Kelvin is just equal to the change in Celsius. Okay, so the final answer for this one, compute it using your calculator, that is 751.66, that is megajoules per hour. However, the final answer should be in HP, right? Or in horsepower. So we should convert this one. So 751.66. I just write here joules per hour. So the mega is also equal to 1 times 10 raised to 6, right? So that's your mega. And we have to convert these to joules joules per second, because joules per second is watts. Okay, so converting the hour into seconds, that's 1 hour. In 1 hour, there are 3,600 seconds. Now that is in joules per second, and joules per second is already in watts. So now we have to convert watts into HP or horsepower. The conversion for that one, okay, so what's the conversion for that one? We have 746 watts is into 1 horsepower. Okay, so that is already the final answer should be in horsepower, and the answer is 200, approximately 280 horsepower. Okay, so that's it. Let's have the next one.